Hello everyone. Today I am going to demonstrate how do we do SIwave with HFSS region simulations in 3D layout. In the current scenario, I have two ICs at each end and one pair of transmission line has been connected through. And now we will be considering a 2.5D solver as well as a 3D solver, right? So we need 3D HFSS regions over the IC component areas over here and as well as here, and we would like to simulate the transmission line by a 2.5D solver. Okay, so now in order to proceed, our first step would be basically defining ports at each end, right? So in order to define ports for IC components, so let's define this side first. So let's select the IC and model it. In the model, we would like to choose the die type. So I'm choosing flip chip over here, and orientation will be chip down and shape cylinder, and the reference has to be auto. Okay. So once we define that, a reference plane would be created. Our reference plane would be created and solder balls would be created for signal as well as ground pins. After that, we'll assign ports. So in order to assign ports on this end, on this IC end, we would be again selecting that similar IC, and then we would go to create ports on the component, and then we'll select the signals to which we have to provide the ports, and the type should be port, and say OK. So once we do that, two ports have been created for these two signals with respect to the this sheet which has been created, and this sheet is directly connected with the ground vias, or you can see the ground pins. Similarly, on the other end, we have another IC which is U2A5. We would do this, repeat the same procedure here. Type and shape can be chosen either cylinder or spheroid, and this by default chooses some gives some diameter and height which can be changed. And then right click again and create ports on the component. So we would be creating ports on the other end as well for the same signal nets, and say OK. So this will create another two sets of ports. Now ports have been assigned. So now we need to define the regions, right? So now we would like to simulate the IC regions where we have most of the discontinuities, and this region as well, the other IC as well, using a 3D solver, right? So in order to do that, let's go to layout and go to stack up. Okay. So in the stack up, if you go to the non-stack up layers are those which are basically not involved in the simulations. Here you see by default one layer has been created, and the name of that layer is known as SIwave Regions layer. Okay, so we will be actually using this layer now. Okay, so let's close that, and now we need to so basically in order to define the HFSS regions, we have to define using that particular layer. Okay, so now we'll go and choose the SIwave Regions layer. So now this layer is active, and now anything which now if we are drawing anything over here on this UI portion, that would be drawn on this particular layer. Okay, so now we would be defining these two regions as HFSS regions using this particular layer known as SIwave region. Okay? So we would be selecting a primitive, a rectangular primitive from here, and then we'll zoom in and define a region. So now if you see on the left hand side on the properties, this is known as a SIwave region. Okay. Similarly, I will take the primitive one more time and draw that. Okay. So now I have defined two HFSS regions over here, right? And the rest of the part would automatically be solved by a SIwave solver. Now, once we define the regions, the next step is basically to add the solution setup. So let's add the HFSS, the 3D solution setup first, which is HFSS solution setup, and we'll go to advanced. So we can enter the solution frequency here. So for now I'm leaving it to single. I'm leaving it to default 5 gigahertz. And then we have to define the sweep for which we want to simulate. Okay. Let's say okay. Now the rest, as we know that the rest of the regions, which is actually this region, the transmission line region, would be solved by a 2.5D solver. So we need to add one more setup over here, right? So we'll go to analysis again. Then we'll go to add SIwave solution setup. Okay. Now say okay to this and leave the, so this is a SI simulation and we leave it to default balanced. Now we have to make sure that the frequency sweep is same for SIwave. Okay. So yeah, this is this same setup which was there in HFSS setup as well. Now in this, if you see 3D solver region here, there is something called HFSS user defined region. So what we are basically doing, we are linking this particular setup in the SIwave setup. Okay, and we'll choose that particular setup which has been created, which is the setup 1 and the sweep 1 associated with the same setup. Okay, so now the meaning of this particular SIwave setup is that it will be, the transmission line region would be solved by a 2.5D solver by using SIwave setup, and we have linked the HFSS setup with the SIwave setup over here. So by defining this, we basically want to say that the regions which are user defined regions are HFSS regions, should be solved using this setup, and rest of the region would be solved by this setup. Okay, so let's say okay here. Now there is another important thing, that is HFSS extent. So in the HFSS extent, we can leave the dielectric type bounding box and leave the horizontal padding as it is. For the air box, we can make the bounding box as 0, the horizontal padding, and leave the vertical padding as it is. Now we have two setups here, one is HFSS and one is SIwave, and as we know that HFSS setup is already linked with the SIwave setup. So now when we are simulating this particular model, we need to right click on the SIwave setup and say analyze. We don't have to select the HFSS setup, otherwise it will simulate the full structure with the 3D solver, right? So in SIwave setup, in SIwave sweep, the HFSS setup is already linked, right? So we have to basically go with the SIwave setup and then say analyze, and then it will solve the IC component regions using 3D solver and the other regions using a 2.5D solver, and then you can plot the results, and the results would not be different for each regions. So it will be a cumulative result for these two regions, as well as cascading the S parameter of this. So the S parameters which you see from here would be basically your end-to-end pole S parameters. Okay, so the S parameters would not be basically different for each regions, right? So now I would like to explain what happens in the background and how the HFSS performs this kind of hybrid simulations in the background. So let's go to the sweep one, and the one important thing is here. So let's say there is a tab for solve regions in parallel. So you can configure it. So how many HFSS regions do you want to simulate in parallel? So here there are 2 regions, so you can say 2, and you can, depending upon the complexity of each HFSS regions, you can define the resources individually. So what we need to do is, we need to basically straightforward go to SIwave and say analyze, and then the solver will basically do whatever I have explained in the background, and then we can, in the end, we can go to the results and say create standard report and rectangular report, and we can plot the S parameters over here. So this is how we do the hybrid kind of simulations, and this actually saves a lot of time as well as computational resources in comparison to when we solve the full 3D structure. and accuracy is also up to a limit, up to the mark. Yeah, so this is how we go ahead with SIwave with HFSS region simulations. Thank you. So we have already done the setup for SIwave with HFSS regions here. Along with the SIwave with HFSS regions design, I have also created another 2 designs. So in HFSS design, I have just given the HFSS setup. So in this case, the full model is going to be solved by HFSS solver. And in SIwave, I have created one SIwave setup here with SIwave sweep. The full model is going to get simulated by the SIwave solver. I've created these two so that I can compare the results and the runtime simulations with SIwave with HFSS region simulations. So I have done the simulations, and after the simulations, we can first go with SIwave with HFSS results. So on the results tab, we have to right click and go to create standard report, and we can go to rectangular plot. And in the rectangular plot, we have to choose the solution first. So here we see 2 sweeps here. One is HFSS setup and one is SIwave setup sweep. So we have to choose the SIwave setup sweep because HFSS is already linked with that. So we'll be able to plot the end-to-end S parameters. And in the domain, we have frequency domain, which is sweep, and we have another domain that is time domain. So we have to, right now we are plotting S parameters. So I'll choose domain as sweep. And then we have S parameters in the category. And in the quantity, we can either choose the self terms, which will be basically your return loss, and in the mutual, you can choose your insertion loss and cluster. So here right now, I am choosing, so here you can choose any particular port for return loss, and you can say new report and you can plot it. So I have already plotted the S parameters of all the 4 ports here. So basically to compare the results, I have copy the S parameters of any one S parameters and compare with the SIwave with HFSS for the same port. So you can copy it from here, copy data and paste it there. Okay. So similarly in SIwave and HFSS also, I have tried plotting the results, and actually I have pasted the results for 3 in this particular in HFSS sweep, HFSS setup only. So the gray one is basically your HFSS, and then you see your navy blue color one. This is basically your SIwave with HFSS regions, and this one, the light brown color one, is basically your SIwave. So as you can see, the SIwave, the only SIwave solver setup is basically not matching with the other 2, which is basically your SIwave and HFSS solver results. So here you can see that SIwave with HFSS region, which is the navy blue one, correlates quite well with the HFSS setup till 20 GHz, and unlike the SIwave solver setup, right? So this is the difference between 3 of them. And as per the simulation runtime, so simulation runtime is basically, this is the plot for the simulation runtime of 3 cases. So SIwave, the only SIwave design actually ran in 3 minutes, and HFSS only took 48 minutes, and SIwave with HFSS regions took 9 minutes and 35 seconds. So so this particular case actually took quite lesser time in comparison to HFSS setup. So yeah, this is what is about SIwave with HFSS region simulations.